In this question, a scientist is carrying out a reaction between two fictional species, T and X. So here's our equation for our reaction. The scientist predicts a reaction mechanism made up of two elementary steps shown in the table provided. So here we can see we've got step 1 of our reaction is that one T combines with one X to form TX. We're told that's a slow step. Then for step 2, two TX combine together to form T2X2, and that is a fast step. The first question here asks us to complete the proposed reaction mechanism table with the rate law for each elementary step. So these steps in the proposed mechanism are elementary. That means we can use our rule for elementary reactions for writing the differential rate law. So here it is down here, the differential rate law for elementary reactions. And that shows us that for this reaction, where reactant A has a coefficient lowercase a and reactant B has a coefficient lowercase b, the order of reaction with respect to A is the coefficient of A, and the order of reaction with respect to B is the coefficient of B. So that's why we get this rate equation with a lowercase a as the order or the power on the concentration of A, and the same for B. So here the order A and B are the coefficients of compounds A and B in the chemical equation. So based on that, in step 1, we have one T and one X. So that means that our rate law is going to have the concentration of T to the power of 1, in other words, just the concentration of T, and the concentration of X to the power of 1, in other words, just the concentration of X. So that's going to get us to this rate law here. In step 2, we have two TX molecules combining together. So for our rate law for this, we've got two TXs. So it's going to be the concentration of TX squared. So that's going to be our rate law for the second step. Okay, next it asks us, which step is the rate determining step? So rate determining, that is going to be our slow step. And that's usually the step with the higher activation energy. So typically when we have multiple steps in our reaction mechanism, one of them happens a lot slower than the other. And so overall, it doesn't actually matter what's happening in the fast step because the slow step is so much slower that the rate is entirely dependent on that. So which step is the rate determining step? It's going to be step 1 because we're told that's the slow step. And then when we're asked, what is the differential rate law for this overall reaction? Well, it's going to be the rate law for the slow step, which is step 1, the rate determining step, because that's going to be so much slower than step 2 that it doesn't actually matter how fast step 2 is happening. Step 1 is the one that is slowing us down. So the differential rate law is just based on step 1 of our proposed reaction mechanism, which is K times the concentration of T times the concentration of X. Okay, awesome. So we've used this proposed reaction mechanism to figure out what the proposed differential rate law would be. Finally, we're looking at our equations for step 1 and step 2 and figuring out what are our intermediates, products, and reactants in the proposed mechanism. So to start with, reactants will be the things that are on the reactant side of our chemical equation at the top here. So T and X are definitely going to be reactants. So let's fill those in first. Then for products, that's going to be the thing on the product side of our original chemical equation. So that's T2X2. So that's our product. So we can see that as well in our equations over here. T and X, those are things we're starting with at the beginning. And T2X2 is something we're ending up with at the end. An intermediate, that's something that gets created and then gets used up during the reaction. So it's not there at the beginning. It's not there at the end. So it's not a product or a reactant. It's only there in the middle. So if we look at our reaction mechanism here, in step 1, we produce TX. And then in step 2, we use up TX. So TX is going to be an intermediate because it gets produced and then it gets used up again. So that's going to be our intermediate here.